Hi everyone, Kat Burnham. I'm the Connecticut State Lead for Advanced Energy United, and I'm really glad to be here. As Claire said at the top of the program, this is a topic that should unite us. GETS and advanced conductors and other solutions. This is what we're looking for. We heard a lot of the problems and challenges in our current energy system, and what gets me up in the morning is that we do have real world solutions. And so I don't want to rehash too many of the definitions. I appreciate Commissioner Dykes giving it, thorough example of what are GETS and advanced conductors, but I want to turn it to the industry folks to help us talk about them in practice. Advanced transmission technologies, or ATTs, are an umbrella term that think about a range of different devices and software and technology. And so I want to turn it to Theodore from CTC Global to talk about another variety of advanced conductors. And Theodore, can you tell me a bit about, what are some of the benefits that you're seeing, and tell us again, what makes these conductors so advantageous to enhancing the grid and helping us make it more efficient and effective?
Sure, Kat, thanks. So I'm happy to talk about this. I think this issue is huge. So Chair Steinberg, representatives, senators, commissioners, council, thanks for having this discussion today. I've spent a career around transmission. I was at ISO New England for 15 years, doing all things regulatory around transmission planning and interconnection and operations. Worked for a transmission developer and renewable energy generator. I came to CTC Global because I see this issue as so acute and existential for everything we want to do in terms of energy policy, in terms of reliability, in terms of economic growth. There's a lot of manufacturing and other growth in Connecticut. And transmission is the element that you need to make all of that happen. And we talked a little bit about what are the costs if you don't do that. You start to run into issues like fuel security costs, Connecticut paying for 100% of certain options to keep certain things around in terms of resources to meet reliability or policy. Transmission really can unlock a number of benefits. So I'd like to talk about that in New England specifically, where I've lived for 20-something years. There was a study in 2020 that ISO New England did, and this was a study I requested with the company I was with at the time. It was an economic study. And it was if you integrated 8 gigawatts of renewable energy resources, so these are price takers in the wholesale market, you would cut the production cost of electricity in New England by 50%. You would cut it in half. And that was incredibly significant. The other finding of that same study by ISO New England in 2020 was you would reduce carbon by 1/3. And that didn't scale because of transmission constraints. And it was hard to get to the 8 gigawatt part that had a number of assumptions behind it. So I went to CTC Global because these issues are so significant. A few words about what CTC Global is. We are the largest manufacturer of carbon composite core advanced conductor in the world. Dan talked a little bit about steel core conductors. I'll show you sort of like what I'm talking about here. So the way you support conductors is you have a core to the conductor. This is ACSR or ACSS. It has a steel core conductor. And then you wrap it in aluminum. This provides structural support. The aluminum moves the power. CTC makes the carbon core. It's a carbon composite core. And then you wrap it in aluminum. It's much lighter. It's really strong. And you can double capacity in an existing right-of-way. You can reduce line losses by about 30 to 40%. And as opposed to 7 years, 8 years, 10 years in the planning process for a new line, this has a deployment of around 12 to 24 months, although it's even faster. We just did a project with Tenant in the Netherlands. That started in September. We saw capacity increases in November. It'll be completely done by May. That went from 2,500 amps to 4,000 amps. It's live line. It's 380 kV. They have a little bit quirkier kV, so someplace between 345 and 500 in the U.S. for that sort of project. And this is important because the issues that we're talking about in terms of consumer costs and reliability and economic growth, the thing you can't get around is time. I mentioned I was at ISO New England for 15 years, and many of those tariff provisions I worked on are still there. It takes a long time. We worked on Greater Boston starting in 2008. I think it was fully energized in 2021, to give you the sense of the scale. And that's why you see folks like Microsoft saying we're going to repower a 3 Mile Island reactor. When that's your fastest, cheapest, best choice, that tells you, where things are. So with this conductor, the carbon composite core, and other companies also make carbon core conductors. The conductor heats up. Steel has a reaction to heat. This is why ovens and your stovetop works. It gets hot. As it gets really hard, it gets pliable. It starts to sag. And so that creates a thermal limit of the line. Carbon has an inverse reaction to heat. It doesn't care about heat. In fact, it gets a little bit stiffer. So it has a lower amount of sag to start with. It's a higher tension, and that means when it gets really hot, it doesn't really go anywhere from the carbon part of the line. And that allows you to move a lot of power. It also allows you to use shorter towers, and that saves a lot of costs for consumers, because towers and foundations are really where you see a lot of project costs. So as I mentioned, we've deployed around 125,000 miles of this around the globe. And it's been deployed in the US as well, but often to solve particular problems. And a lot of what you'll hear is, an ACCC is what this is called. Oh, that's more expensive. But when you look at a project cost, whether it's asset condition, as Commissioner Dykes mentioned in New England, a lot of those have rebuilds because you want to put up bigger conductors that are heavier. I have to put up a new structure, or my old structures are in bad shape. When you're using something like this, your sag is lower. You're saving like 8 feet or more off a tower height, and that actually works out to somewhere between 2 to 13% cheaper costs on a project basis of even an asset condition project costs. When you're talking about doubling capacity with an advanced conductor in an existing right-of-way versus building new lines, if I'm doubling the capacity and I'm avoiding a new line, that's a 75% savings for consumers over doing it. And I'm getting the 2 times capacity, I'm getting 30 to 40% less line loss, and I'm getting the wildfire mitigation of the lower sag. So Dan, I mentioned some case studies. I think that's incredibly useful. I'll give 2 really quick ones, Kat, and then we can get into some questions around it. So one I'll mention is AEP did a project in 2016. This was in Texas at 240 circuit miles. It's about 1,500 miles of ACCC. It doubled the capacity. It reduced line losses about 30%. It was done live line. It was the EEI project of the year that year. It's next to the Gulf of Mexico, and it has a non-corrosive effect when we use the carbon. So this will be in service for many more years than if it was a reactive type material. And that even just the energy savings, putting the capacity increase aside. So Dan mentioned efficiency. Reducing line losses by 30% equated to saving $15 million a year just in energy costs, and it was the equivalent, just doing that one transmission line, of adding 34 megawatts to the grid. And if you need sort of an analogy to think about it, think of an LED light bulb versus an incandescent light bulb. You remember those used to be really hot? I remember as a kid I burned myself on an incandescent bulb a couple times. It's why the Easy Bake Oven works, because it's giving off heat, right? So if you are operating at a much cooler temperature, and a carbon conductor operates at a much cooler temperature, you're saving a tremendous amount in terms of heat. And heat is just electricity going into the air. If you improve it by 30%, that's like adding a 34 megawatt generator to the system just by replacing the line. So that was one example. And the other example I gave, I mentioned about the Netherlands on the timing. That was another live line example. But we have those projects around the world, again, doubling the capacity of it. If you think about New England and you think about costs to consumers, going back to that ISO New England study, if you are integrating low cost or zero bid cost generation, that's an immediate cost benefit to consumers. But it's also moving power around the system to really start to solve things like your fuel security issues, which is really spiky. In 2017-2018 winter, we had fuel security issues. We had a cold snap, you might remember. It lasted 15 days. The price of natural gas spiked, and we added $1.6 billion, right? We talk about the cost of transmission. $1.6 billion, not amortized over 40 years like a transmission line, but amortized over that year in additional natural gas prices, just to deal with our current resource mix at the time and some of our lack of transmission capacity, being able to move power around at the time. So new transmission can be cost effective with even what we're talking about today, but it really can start to unlock some significant consumer savings going forward. So it's one of those things where if you're spending money, you can often save significant amounts of money given the way wholesale energy markets work and some of the things we need to pay for if we're not doing it to ensure reliability.
Thank you, Theodore. Yeah, I think savings is a word that is appreciated by everybody in this room. So it's very encouraging to hear that these are technologies that can move more power through the lines. It can help us integrate more renewables and also offer real savings to ratepayers. I think that's the types of solutions that we're looking for.